Okay, picking back up where we left off on number 13 here, we are given a graph and we're asked to determine if the graph represents a polynomial function. And if so, we're going to assume the end behavior and all turning points are represented on the graph. And then we're going to answer these questions. So question A asks us to determine the minimum degree of the polynomial based on the number of turning points. So for this, we need a very simple formula. So you should have this on your cheat sheet. Very simple formula to find the minimum degree, and that is the degree is equal to the number of turning points, or number of turns, plus 1. That's super important. Don't forget the plus 1. So what does that mean? Well, we look at our graph and we count the number of times it changes direction or it turns. For instance, here's a turn, and then here's another turn. So total, that's 2 turns, right? It's going up, it changes direction, that's 1 turn. It's going down, it changes direction, that's another turn. So this particular graph has 2 turns, and then of course we need to add 1 to that. So our degree, our minimum degree, is 2 plus 1, which is 3. So we know the minimum degree of this graph has to be 3. Well, that eliminates this guy that has a minimum degree of 2. This is a polynomial function, and we've got 2 answers here now, A and B, that have a minimum degree of 3. So how do we figure out the rest of it? Or which one is the right answer? Well, let's look at our graph. Look at the shape of our graph, and particularly the ends of our graph, right? The left end is going down and the right end is going up. And you may recall from your notes, I put this handy cheat sheet here, right? We've got a bunch of shapes of graphs here, and it tells us whether the degree is even or odd, negative or positive leading coefficient. So what does our graph look like again? Well, it goes down on the left, up on the right. Which one of these does that match the most? Looks like this one. Down on the left, up on the right. So this is an odd degree polynomial with a positive leading coefficient. Okay, odd degree, positive leading coefficient, because our graph goes down on the left and up on the right. And there's only one answer here that has a leading coefficient that's positive in an odd degree. And that's answer B. Answer B shows that our minimum degree is 3, which we got from up here. And it says the leading coefficient is positive and the degree is odd, which we got from our chart, positive, odd. So B is the only option there. If you wanted to go further and look at the zeros just to prove it some more, you could. We've got zeros or x-intercepts here at -2, 1, and 2. And what is it doing at each of those x-intercepts? It's crossing straight through, right? It's not just touching, it's crossing through each of those. And when it crosses through, what does that mean? Back to this handy sheet. If it crosses through, that means it's an odd multiplicity because it's a degree of 1. So odd multiplicities for each of our zeros further confirms that B is our answer. But if I was taking a test, I'd count my number of turns, I'd add 1 so I could narrow down my answer choices. Then I would look at the end behavior of the graph, find the corresponding match on my cheat sheet, And that would tell me all the information I need to know as far as leading coefficient and degree. Okay, enough of 13. Let's go to 14. 14 wants us to simplify the expression and then state the restrictions. So let me copy this down. My recommendation on problems like this is to definitely factor everything you can factor. So on the numerator, I know this is a difference of squares. So I know that's going to factor out to q minus 2q plus 2. Again, because it's a difference of squares, so we just need to square root really both pieces here. But the square root of 1 is 1. And the square root of 4 is 2. Okay. For the bottom, we're going to need to use the AC method or quick factoring if you're comfortable with that. Since the leading coefficient is 1 here, I know that I'm just looking for two numbers I can multiply to get negative 14. But those same numbers have to add up to negative 5. And doing that math in my head, I know I'm going to have q minus 7, q plus 2. And again, that's because negative 7 times 2 gives us negative 14. And negative 7 plus 2 gives us negative 5. Once you have everything factored, I recommend doing kind of the second part of this problem first. Find your restrictions right away. Find your restrictions. How do we do that? Well, restrictions come from the denominator. Right? Anything that makes the denominator 0 is going to be a restriction because we can't divide by 0. And my iPad is freaking out there. Okay. So let's take the factors on the denominator, set those equal to 0, and solve. And again, we're solving for our restrictions. Q minus 7 equals 0. Q plus 2 equals 0. Everyone should be comfortable solving those. So I know I'm going to get an answer of 7 as well as an answer of negative 2. So 7 and negative 2, those are our restrictions. And it looks like the answer choices, all they wanted were the restrictions. So our restrictions are 7 and negative 2, and answer D is the only one that has that. So that's it. We only needed to find the restrictions. But let's simplify this just for the heck of it, just in case. So we found our restrictions. Now, if we are going to simplify this, we just need to cancel things from the numerator and the denominator. Well, what do the numerator and the denominator have in common? They both have a q plus 2 that we can get rid of. So if we cross those factors out, whatever we're left with will be our simplification. So q minus 2 over q minus 7. This would be our simplified form if they asked for it. But again, it looks like this one just asked for the restrictions, which was 7 and negative 2. All right, number 15 asks us to evaluate a function for the given value of x. I'm going to kind of color code these. F will color code as blue. G will color code as red. And they're asking us to find this right here. G of f composed of 2. So they're asking us to find G with f inside of it with a 2 inside of that. In other words, we always work our way from the inside out. So f of 2, what is that? Well, here's our f function. We're going to plug 2 into that. 2 squared minus 3 times 2. Wherever we see an x, we're replacing it with 2. If I go to my calculator, 2 squared minus 3 times 2 is negative 2. So when we plugged 2 into our f function, we got negative 2. And now that negative 2 gets placed inside of our g function. G is right here, 3x plus 4, so we're going to replace the x with negative 2. Again, I'm going to go to my calculator so I don't make any math errors. And I get a final answer of negative 2. It looks like that's answer choice D. Moving on to 16, we're asked to graph this function. If I'm on a test, I'm plugging this right into my calculator, but we can do most of this by hand here. We've got our denominator and our numerator, and we should know that the denominator tells us where our vertical asymptote occurs. So let's figure that out real quick. If we set the denominator equal to 0, that gives us our vertical asymptote. If we solve it, so that's going to be x equals 4. So we should have a vertical asymptote, or an invisible vertical wall, at x equals 4. So which one of these graphs, come on iPad, which one of these graphs has an invisible wall, or a dotted line, at x equals 4? This one has one at negative 4. That's not correct, so he's eliminated. The other three look like they all have vertical walls at 4. So we were able to eliminate one answer. The numerator gives us our x-intercepts. So if we set this numerator equal to 0, and solve it, that gives us x equals 3. So that tells us we should have an x-intercept, meaning the graph, the blue part of the graph, should cross or touch the x-axis at 3. So let's find which one of these remaining graphs has that. Well, looking at A, here's x equals 3 right about here. The blue part of the graph is not touching that at all. So I would eliminate this graph. Let's go look at these other two, and both of these actually look like they have x-intercepts right at 3. So we need something else. How about our horizontal asymptote? Horizontal asymptotes, if we have the same number of x's on top as we do on the bottom, remember we divide those leading coefficients, which in this case is 1 for both of them. So if we divide 1 over 1, we get 1. Y equals 1 is our horizontal asymptote. And out of the remaining graphs, it looks like there's only one that has an invisible horizontal wall, or a dotted line, at y equals 1, and that's this guy right here. So it looks like B is our answer. Notice D has a horizontal line at -1, which is incorrect. So that's out. So B was our only choice here. We've got our vertical asymptote at 4. We've got our x-intercept right at x equals 3. And our horizontal asymptote at y equals 1. Okay, so that was 16 and 17. This should be a gimme. Really shouldn't miss this problem. we're given a domain of a function, of a one-to-one function. We're given the domain and the range. Okay, so they tell us the domain is -9, 3. So I'm going to write that down, -9, -3, sorry. And the range they state is -7 to infinity. Well, the thing with, so what they're asking is for us to state the domain and range of the inverse of the function. And the thing with inverses is that the x's and y values, they just swap. Same with the domains and ranges. The domain of the original function becomes the range of the inverse, and vice versa. So our inverse function is going to have a domain. Maybe I should show it like this. The range of the original becomes the domain of the inverse. Similarly, the domain of the original becomes the range of the inverse. So we should be looking for an answer choice that has a domain of -7 infinity and a range of -9 to -3. And it looks like B is the answer choice here. Domain of -7 to infinity, range -9, -3. Yeah, that's it. So again, inverse functions, the domain of the original becomes the range of the inverse. The range of the original becomes the domain of the inverse. We're just swapping places. Number 18, we're given an investment and an interest rate and a certain period of time. So we should be thinking compound interest formulas. We've got $13,000 invested at 5.5% interest for 6 years. And man, do we have to pick which one is correct? That's interesting. I'm going to have to look back on this problem to see and make sure there wasn't some information that didn't get copied in here. But what we can do is maybe start with the continuous compounding, because it looks like, oh, no, I see what they're saying. Scratch that. They're saying part A is compounded annually. Part A is compounded annually. Well, if we're compounded annually, we should know that that n value is 1, because that's once per year. Okay? So right away, we can eliminate some of these answers. Annually doesn't mean the n value is 365. That's incorrect. So this guy's out, and this guy's out. We know annually means an n value of 1. Okay? An n value of 1. And let's recall our formulas here. We've got A equals P times 1 plus R over N raised to the N times T. That's compound interest formula. But if we're compounded continuously, we need to remember that we've got this formula. A equals PE raised to the R times T. In any case, let's do our compounded annually first. We know P is going to be our $13,000. We know R is 5.5% interest, but remember, we need to make that a decimal. That would be 0.055. If you don't know that, just take your percentage and divide by 100. And that'll give you the proper decimal to use. So in this case, it's 0.055. The time is 6 years. And of course, annually, we talked about, means once per year. And we just plug that in to the formula. So we're going to have P parentheses 1 plus R 0.055 over N, which is 1, raised to a power of N, which is 1, times T, which is 6. Hopefully you can see that. And at that point, we go straight to our calculator. We're not messing around here. We're just going to go to our calculator and type that in just the way it looks. So 13,000 parentheses 1 plus 0.055 over 1, close parentheses, raised to a power of 1 times 6. And that's 17,924.96 if we round it. And that didn't help us at all because both of our options that we have left have that answer under annually. So again, remember, we eliminated A and D because annually doesn't mean an N value of 365. That would be daily. So that's incorrect because they're asking us for annually, which is an N value of 1. So we eliminated those. Our only answers left both have the correct result for compound interest annually. So we only have our only choice, our only option is to calculate continuous compounding and compare those. So let's do that. If we plug in our values here, everything remains the same. P is 13,000. E is just a button on our calculator, raised to the R, which was 0.055, times T, which is 6. Going to our calculator, E raised to the 0.055 times 6 gives $18,082.59. And the only one that has that is not this guy. Looks like C, $18,082.59. So C is the answer there. So just to kind of recap, we're giving these values some money invested at some rate for 6 years, and then they're asking us for part A to calculate compounding annually. What is that N value? That's 1. And then what is the result? And then they're asking us to calculate compounding continuously. Well, the N value doesn't matter in compounding continuously. And then what is the result? And the table that has the correct values is right here. Okay, number 19, we're to logarithms, and we're asked to split this logarithm apart and write it as a sum or difference of logarithms. So we're going to have multiple logs using addition and subtraction. Well, remember, each term gets its own log, so let me just circle my terms here. In my numerator, I've got this term, and in my denominator, I've got b cubed and a c. So I've got 2 terms in my denominator. So I'm going to have 3 logs. I'm going to have log base 7. So let me just write those out. Log base 7. I know I'm going to have 3 of them. Log base 7. Numerator goes in my first logarithm. Denominators go into the other logs. And then remember, anything on the numerator is a positive log. Anything in the denominator is a negative log. So I know these two logarithms here are going to have minus signs. After that, we just need to remember the power rule, which states if we have an exponent in a logarithm like this, we can move it to the front. So our final answer here will be 5 log 7a minus 3 log 7b minus log base 7 of c. And that answer is A. Answer choice A. We want to graph the function and state the domain and range. Probably if I have a graphing calculator, I'm going to just type this in. But we don't have to. We could make a table. So if you don't have a graphing calculator, this is what you would want to do. Okay, and we're going to pick some values. I always like to choose -2, -1, 0, 1, and 2. Those are just arbitrary choices. I choose them every time because they're small numbers. We've got a couple negatives, we've got 0, we've got a couple positives. So it'll give us a good idea of what the graph looks like. So let's start with -2 here. We're going to plug that in for x. 3 to the -2. Well, we could use our calculator, 3 to the -2, and make it a fraction. That's 1/9. Similarly, 3 to the -1 is 1/3. Anything to the 0 power is 1. 3 to the 1 is 3, and 3 squared is 9. So then we could plot those points. -2, 1/9. Well, let's make our own graph here. Making sure I have enough ticky marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it doesn't have to be perfect. We're just trying to get an idea here. So let's see, -2, 1/9. What would that look like? -2, 1/9 is a really small fraction, not even super close to 1, just really close to 0. So maybe there. -1, 1/3, slightly higher. 0, 1, 1, 3, 2, and 9. So that gives us an idea of what our graph is doing, something like this. So right away we can see not this guy, doesn't have the right shape. Not this guy, doesn't have the right shape. So we've eliminated A and D. Now we're down to B and C. Both of those look like identical graphs to me. So now it's coming down to domain and range. This is an exponential function that hasn't been transformed, right? There's no other numbers here being added or subtracted to it. It's just an exponential. Notice this thing doesn't go past the x-axis. It doesn't go past the x-axis. But it does go left forever, and it's going up and to the right forever. So if it goes left forever and right forever, that means the domain, the x values that are covered by this graph, are negative infinity to infinity. Domain is negative infinity to infinity. Again, this graph goes left forever and it's going right forever. Yeah, it's going up, but it's not going straight up. It's going towards the right side, right? It's going right to infinity. The range, well, how low does this thing go? The lowest it goes is to the x-axis, which is a y value of 0. Never actually hits it, but it gets infinitely close. So that's 0 with a parentheses, and then it goes up forever. So we're picking the graph that has a domain of negative infinity to infinity, which there's only one. And then we can check the range as well to make sure that matches, which it does. Let's see here, 21. Solve the equation. Write the solution set with the exact values given in terms of natural or common logarithms, and then give the approximate solution to 4 decimal places. Alrighty, so let me write this down. We've got 8e to the 4m minus 3 minus 5 equals 43. Goal here, we want to get this e term by itself. So we want to get anything else that's hanging out over here, like this minus 5 and then this 8. We want to get those out of there. How can we move this minus 5? Well, we do the opposite. Add 5, and whatever we do to one side, we do to the other. So that's gone. And now we've got 8e to the 4m minus 3 equals 43 plus 5, which is 48. Next up, we want to get rid of this 8 that's being multiplied by e. And to undo multiplication, we use division. So we're going to divide both sides by 8. Leaving us with e to the 4m minus 3 equals 6. Now that we've got the e by itself, we're ready to introduce logarithms. We can take the natural log of both sides. Because natural log is the inverse of e, we can think of it as kind of canceling out this e. What's really happening is natural log of e is 1 and the exponent comes down, but that doesn't matter. We're taking the natural log of both sides here. That's what you should remember. So we're taking the natural log of both sides because for all intents and purposes, natural log cancels out e. Okay? That leaves us with 4m minus 3 equals natural log of 6. And now we're just solving for m. Right? Natural log of 6 is just a number, so we leave it there. Treat it like a number. Let's get this m by itself. So we're back to doing opposites. Add 3 to both sides to get rid of this minus 3 on the left. So now we have 4m equals natural log of 6 plus 3, right? That plus 3 is not a part of the 6. We can't combine those because this 6 is really inside of that natural log function. Last step here is to divide by 4. So we've got m equals natural log of 6 plus 3 over 4. And which answer choice would that be? Natural log of 6 plus 3 over 4. There's only one choice here, and that's this one. We want to be really careful we don't accidentally choose something like b. Looks really close to our answer, natural log of 6 plus 3, but b has a natural log on the denominator, which we did not have here. Okay, so C is the correct choice there. And if you wanted to plug this in your calculator and make sure it matches the approximate value there, you could. Natural log of 6 plus 3. And yeah, that matches. So that was 21. For 22, we're solving a logarithm. And if you were in the review sessions for logs, you might remember this is one of our golden cases. When we have a single log equal to another single log, we just drop the logs. So let's write what we have left. And what we have left is a quadratic. We just need to get this thing equal to 0 so that we can use our factoring knowledge. So now we're looking for two numbers we can multiply to make negative 21, but those same two numbers have to add up to negative 4. I'm thinking negative 7 and a positive 3. Negative 7 times 3 is negative 21. Negative 7 plus 3 is negative 4. Setting each of those equal to 0. And solving. I'm getting x equals 7 and x equals negative 3. Now we would just want to check those answers. So how do we check these? Well, I recommend just plugging the number into the parentheses. And we just want to make sure we don't get a negative number or 0. So we're plugging it in for x. If I plug a 7 in there, what does that give me? Well, that's 7 squared. Notice the parentheses. Minus 4 parentheses 7. That's a positive number. That's positive 21. That's good. 7 should be okay. Let's check negative 3. So again, in parentheses, I'll put negative 3, and then that's squared. Minus 4 times negative 3. Really don't forget those parentheses wrapped around whatever number you're plugging in. And that's also a positive 21. So both of those answers worked. I wasn't expecting that to work, but it did. So 7 and negative 3 are our answers, which is answer choice C. Alrighty. Here's another one, solving a logarithm equation. This is not one of our golden choices or golden setups because we've got two logs on one side of the equal sign, and this is no good. We need to combine those into one single logarithm. So we got to use our log properties for that. And since these two logs are being added, remember, addition corresponds to the product property. So we can combine these into one single logarithm using multiplication. So we'll have n minus 2 times n plus 5, and that's equal to 3. Now we've got a golden setup. One single log equal to a number. We just need to remember the base of the logarithm raised to this exponent equals the stuff inside the logarithm. So we know 2 to the third power equals n minus 2 times n plus 5. And now it's a quadratic, so we can start solving this. 2 to the third is 8. If we FOIL this out, hopefully everyone's okay with foiling or the handshake method. I'll leave that to you all, but you should get n squared plus 3n minus 10. And now we just need to get this thing equal to 0 so that we can factor or use the quadratic formula. I'm going to factor. I know that two numbers I can multiply to make negative 18, but add up to 3 would be a positive 9, so n plus 9. And no, that's not right. Way to go, Pete. This would be a positive 6 and a negative 3. And let's test that. 6 times negative 3 is negative 18. 6 plus a negative 3, positive 3. And of course that's equal to 0, so we're just going to set our factors equal to 0 and solve. I'm getting negative 6 and a positive 3. But we need to test these out, so we're going to go back up to our original problem here. All the way back to the beginning. Not to our condensed one, but up here, just to be safe. And let's test negative 6 first. So we're going to plug negative 6 in here, and then we're going to plug it in here. If it doesn't work in either of those, it doesn't matter which one, then we have to throw our answer away. So let's plug negative 6 in here first. That's negative 6 minus 2. That's a negative 8. Not going to work. Remember, we can't get a negative number. We can't get 0. In this case, we got a negative 8, which is, of course, a negative number, so that's out. Negative 6 didn't work for us. Let's test 3. If we plug 3 in here, 3 minus 2, that's 1. That's okay. 3 plus 5, that's 8. Positive number once again, that's okay. 3 works out for us. It didn't give us 0 or a negative number when we tested it out. Okay, so that one's there. And I think that's it. Yeah, so 3 is our answer. 24. pH problem. They give us the pH formula, which I'll write a little bigger here. pH equals negative log H plus, but I like to just write the X in there. And then they give us a pH. They say, hey, the pH is, in this case, 7.3. So we're going to plug that in to the formula. 7.3 equals negative log X. We're going to divide both sides by negative 1 because we don't want this negative 1 hanging out here. That leaves us with negative 7.3 equals log X. At this point, we should know that the base of this logarithm is 10, because if we don't see a base, the base is 10. Base raised to this power equals the stuff inside the log, which is what we want. We want to know what X is. So 10 to the negative 7.3 equals X. Now at this point, we want to, if we have a graphing calculator or a scientific, make sure you go to Mode and Scientific and hit Enter, just for this problem, the pH problem. And then you can quit out there and you can type this in to be sure that it gives you the answer in scientific notation. So 10 to the negative 7.3. 5.01. And we've got that E negative 8 in the calculator, so that means times 10 to the negative 8. And just one quick hint for these pH problems. You're always going to end up here, meaning you're always going to end up with 10 raised to the negative of whatever pH they give you. You're always going to end up here, and then you're going to go to your calculator and type it in. In this case, it gave us 5.01 times 10 to the negative 8, which is answer choice B. Okay. Matrix problems. Most of these matrix problems are gimmes. We're really just copying and pasting numbers into different places. So, for instance, in this problem, did I not write the number there? This is number 25. In this problem, they want us to write a system of equations represented by the augmented matrix. So we're just pulling these numbers out and writing equations. Remember, this is x, the middle column is y, and the last column is z. So this first equation here, yeah, maybe I'll just do it up here. This first equation is negative 7x, positive 4y, minus 8z equals negative 5. Next equation, 3x plus 8y plus 8z equals negative 12. And final equation, 4x minus 8y plus 4z equals 1. Now we just got to make sure we very carefully find the answer choice that matches those. Negative 7x plus 4 minus 8 minus 5, 3 plus 8 plus 8, and then a negative 12. 4 minus 8 plus 4 and a positive 1. Looks like B is our choice here. Too easy. Should not be a problem you miss on the test. We're just copying and pasting numbers, so don't get overwhelmed, but really, really make sure you carefully read these instructions as well. Don't try to jump into solving these. A lot of students will see this and they'll start doing, Gauss Jordan or going to their calculator to solve it. Not what they're asking. They just want you to rewrite the matrix as a set of equations. That's it. So read these matrix problems carefully. 26, again, reading this carefully. I still have some work there from Friday's session. But reading this carefully, they want us to write the matrix for the given set of equations. So we're just taking these equations and rewriting them in matrix form. We're not solving anything. We're just copying and pasting values. So, keeping in mind, we've got x, y, and z. For this first equation, I can see that our x term has a 1 in front of it, the y term has a negative 5, and the z term has a 3. And then the answer is 4. In the second equation, there is no x, so I can think of that as being 0x has a negative 4 for y and a 5 for z, and then an answer of 8. And then in the last equation, there's not an x or a y. So I can think of those as both being zeros. There's a negative 5 for z. And then the answer is 7. So I'm just, again, very carefully making sure I don't mess up any signs, looking for the answer choice that matches this. 1, negative 5, 3, 4. 0, negative 4, 5, 8. 1, no, so that does not match because we had a 0 here. So that's not it. This one is not it because it also has 1s here. Looks like C. C is the only one that matches. Okay, again, read these very carefully. They just want you to rewrite the matrix or rewrite the equations in matrix form. We're not solving anything, just rewriting. And then, of course, be really careful when you're searching through your answer choices because some of them get real close to being correct, but they're just one number off. 27, we're writing a system. Again, we're just writing. We're not solving anything. We're writing a system of equations that are represented by this matrix. So I'll go through this one quickly. We only got two variables here, right? Because those are separated. Our answers are on the other side of this line. So we've got 3x plus 3y equals 8. And then we've got 2x minus 3y equals negative 9. And that's it. Looks like that is answer choice A, I believe. Yeah. $28, again, just writing the equations represented by this matrix. You might notice your answer choices only have like one variable for each of the equations, which kind of makes sense because if you look at this matrix, let's write this out. This first equation would be 1x plus 0y plus 0z equals negative 1. Well, 0y and 0z, we can ignore those. Those are just zeros. They get zeroed out. So really, we can think of this equation as x equals negative 1. Similarly, for the second equation, 0x plus 1y plus 0z equals 6. Those 0x's and 0z's, those are gone. We can think of this as just y equals 6. And for the third equation, 0x plus 0y plus 1z equals 1/9. The x's and the y's are zeroed out. So really we just have z equals 1/9. And if we match those, looks like B. Finally, 29, let's see here. 29 is a word problem, but again, it's not asking us to solve. They just want us to determine the system of equations that represent the situation. So if Jessica goes to a soccer game and buys 2 orders of nachos, 3 Snickers bars for $9.66, we can set up an equation for that. 2 nachos, 3 Snickers bars, 2x plus 3y equals, what was the cost? $9.66. And then Brandon bought 4 nachos, so 4x, 2 Snickers bars, so 2y, for a cost of $11.62. So again, no solving required. They just want us to come up with a system of equations. And this one looks like it's A. And we're done. $30 is asking us to solve another word problem very similar to the last one, but this time they want us to determine the cost of the items. Determine the cost of the items. So let's come up with some equations here. We've got 4 Dr. Peppers, 3 Snickers bars for a cost of $16.45. So let me write that out. That's 4 Dr. Peppers. Maybe I'll use D for Dr. Pepper. And then 3 candy bars. So I'll do 3C for candy bars. Equals $16.45. And then we've got 3 Dr. Peppers and 5 candy bars for $18.36. 3 Dr. Peppers, 5 candy bars, $18.36. So those are our equations. Then we're going to convert those to an augmented matrix. So I've got 4, 3, 3, 5, 1645, and 1836. Now at this point, we want to, remember the goal is to get ones on the diagonal and zeros in these places here. So I think I'll start by getting a 1 right here. Anytime you want to get a 1, you're going to be dividing by whatever number is sitting in the place that you want that 1. So in this case, we're going to divide row 1, which is this row. We're going to divide it by 4. Row 1 equals row 1 divided by 4. So what does that do? Well, it didn't change row 2. But it did change row 1. 4 divided by 4 is 1. 3 divided by 4, let's go to our calculator. 3 divided by 4, that's, oops, I didn't switch back from scientific mode from my pH problem, so I need to go back to normal mode. And 3 divided by 4 is 0.75. And we got to divide this as well, so 1645 divided by 4 is 411. Okay, we got our 1. Now we want to get a 0 in this spot here. Well, to get a 0, I need to add a -3 to this, in this case, because this is a positive 3, right? So I need a -3 that I can add to that. So maybe we'll say row 2 is going to be -3 times row 1. And again, since we have this 1 up here, we can think to ourselves, okay, what could we multiply this by to get a -3? Well, that's a -3. -3 times 1 is -3, and then if we add that to this guy, we get 0. So we're going to do -3 row 1 plus row 2. Row 1 is not going to change. We're just multiplying it and then adding that result to row 2. So -3 times 1 is -3, and -3 plus 3 is 0. -3 times 0.75 plus 5, I don't know what that is. 275. And then -3 times 411 plus 1836. 603. And we got our 0 in this spot. Now we want our 1 here, and remember, if we want a 1, we're just going to divide the entire row by the number that's sitting in the place where we want the 1. So row 2 is changing. We're going to change it by dividing by 275. Okay. Row 1 hasn't changed, so we'll just write that in there. But row 2 is changing. We're dividing by 275. Well, 0 divided by anything is 0. 275 divided by 275, that's going to give us 1. And 603 divided by 275, going to my calculator, is 219. Okay, almost done. We just need to get a 0 in this spot. So what can we multiply this 1 by that we can then add to this to get a 0. Well, we need a negative 0.75, right? So now row 1 is changing. We're going to change row 1 by multiplying row 2 by a negative 0.75, multiplying that by row 2, and then adding the result immediately to row 1. So row 1 is the only row that's changing here. We're just using row 2 to help change it. So in this case, row 2 is finished. But we're going to do negative 0.75 times 0 is 0, and 0 plus 1 is 1. Negative 0.75 times times 1 is negative 0.75, and negative 0.75 plus 0.75 is 0. And then negative 0.75 times 219 plus 411. So I just typed it all in there. It's 2.47 if we round. So, what did we learn here? We've got Dr. Pepper is 247, and our Snickers bar, or our candy bars, are 219. It looks like that's answer choice D. Okay, so solving matrices. But again, on the exam, remember, read these instructions carefully because they may not want you to do any solving at all. For the majority of these problems from the review, we were just asked to rewrite the matrix as a set of equations, or to rewrite a set of equations as a matrix. This was the only one where we actually had to solve, so read these instructions carefully. I think that is it. So hopefully that was helpful. Again, email me if you have any questions, if you're stuck on any one of these problems, and I will help you out. So happy studying.